Okay, so I wanted to show you something real quick. As you walked in, you grabbed your Chromebook, you grabbed your calculator, you grabbed the notes in the back. Just for today, I have all of this stuff here. Okay, I have here up on the board, where you can't see on the video right now, but you have the quality questions. How can we use existing info to make predictions? Are there limitations on how we can use regression to make predictions? Those are two big kind of questions that we're thinking about today. Okay. Also over here, shows basically the plan of the day of what we're doing. Okay. The 3 warm-up questions, the forms, supplies, regression form data. We kind of did that a little bit out of order. Now what we're going to do is notes and homework. Now over here, we're doing this right now for you. You have the date. You have the, let me highlight as I go. You have the date, A day, B day. You have the objective. Look at those quality questions that I just showed you. And then what we're doing that day. So today is day 2. And those quality questions are right here that I just read to you that were shown on the board. Okay? And what's going to be cool about this is that in your Google Classroom, if you're absent and you go to this schedule, you can basically click on what these links are, and they will take you straight to whatever it is that we're talking about. Okay? As far as where's the worksheet, where can I find this worksheet, so on and so forth. Okay? Let me go back. Okay? And then, like, what we're going to do here in just a bit is go over this domain and range. Guys, not only will this be online so that you can see if you wanted to print it off at home. If, let's say you had a dental appointment during my period, and you printed this off at home and didn't wait to come to class to get from that folder of what you missed, there'll be a video online as well that you could just follow along with it if you want at home, and you can catch up that night. Okay? Please do that. There's not enough time for tutorials to catch you up in that respect. There's not. Okay? Any questions for that, as far as that goes? All right. So let's go ahead and we're going to look at. Let's see. We're going to look at these notes to start off, and these are the notes for today. Okay. And we're going to start with domain. A domain is a set of all, okay, here we go, a set of all possible input. Notice what's capitalized, x values, or values of x. Okay? Over here, a range is the set of all possible values that are y. And these are output, so put output values. All right, so let's make this kind of a real world type of example. Over there near the cafeteria, we know we have those 4 Coke machines or whatever they are, right? The domain is the allowable inputs. Guys, what can you put into those machines to get your drink? You can put money, right? But you can put quarters. Quarters is in the domain. It's an allowable input. What else can you put? Dollars, dimes, nickels. I don't think it takes pennies. But it takes all those silver coins, right? It even takes Apple Pay. All of those are allowable inputs. What are the outputs? The drinks. The drinks is the soda that you get out, the tea that you get out, whatever it is, those are output Y values. Yes. Or extra change. Hey, touche. So extra change, if you pay too much, is another output. Okay? Alright, so now let's move on to what we were talking about last class, dealing with continuous. It's a graph, is an unbroken line, or curve, underline curve, because a lot of them are not lines. They could be different shapes with no gaps or breaks. wanted to write drawing a graph without lifting up your pencil, you're more than welcome to. Without lifting up your pencil. Discrete is a graph that has holes, gaps, and breaks. Or breaks. Okay? And if you want to write underneath just a bunch of points, that's fine. Okay? All right. Algebraic notation. Algebraic notation is going to describe a set of numbers using algebraic symbols. Okay? So let's say describe a set of numbers using algebraic symbols. Oops. Okay, and we're going to put no braces. These are braces. Okay, so let me do that a little bit clearer. That's a brace. And this is a brace. So an example could be something like this. I could say that the domain is between 0 and 2, where 0 is less than or equal to x, which is less than 2. Or you could also say like 8 less than or equal to x less than or equal to 12. These are just examples, guys, of a domain. Whereas a range, i.e. the y value, so this one's x, these are y's, would be y is greater than 4 or like negative 5 all the way to 2. So you have the less than or equal signs on this. And you could write that here if you want. You could put less than or greater than, less than and equal to, or greater than or equal to. That's the algebraic notation. Okay? The interval notation, let's jump down to interval notation. The interval notation is going to basically be the same, but we're going to use parentheses and brackets. Okay? So we're going to say use parentheses to represent values not included. And use brackets to represent values. These are just ditto points like quotations. Just it copies whatever's up top that are included. Those ditto or those quotations are just so that you don't have to copy word for word and you can actually look up and ask questions. Examples of this. Now look carefully. This one includes 0, includes 8, includes 12, includes 5, and includes 2. These do not include 2 and do not include 4. So we're going to put this first domain that we have up top, we're going to say from 0 to 2, bracket, bracket. And also you could say from 8 to 12, bracket, bracket. Sorry, I did not mean to put a bracket on this too. What should I have put? Parentheses. So parentheses on the 2, brackets on everything else. Okay? And over here on the range, we're going to put y's that are greater than 4. So that means I'm going to start at 4 and go to infinity. Parentheses on both. This one I'm going to start at negative 5 and I'm going to go to 2 and I'm going to bracket on both because I'm including both of them. And I want you to put this nice union sign right here. Okay, that means both of those intervals. And yes, you could do the same thing over here. You could put union 8, 12 with brackets, and it could be that answer right there. Questions of what we have right now. Okay, so which one seems easier, interval or algebraic? Algebraic, okay. When we start looking at graphs, I think the interval will pop out just a little bit faster, okay? We'll see that in just a bit. Now, a lot of you are dressed very nice today. We'll say that that's the algebraic, and the set notation is a formal, it's a formal type of algebraic. And this is like those of you who want to do theory and higher level math in college, okay? It's just saying this, like the domain that we looked right here. We would say the set of all x's such that, and then you would just copy what you see. 0 is less than or equal to x less than 2, and on the same line, 8 is less than or equal to x less than or equal to 12. Close brace. It's the same thing as algebraic, it's just a little bit more formal. And then over here for this range, it'd be the set of all y's such that y is greater than 4, and then all of this. Close the brace. Questions? So we have interval notation. I think you should probably do this one first. And then I would go to algebraic. And then I would end on set notation. You have to know all three of them, okay? It's just the way we're defining where our input domain values occur and where our output range values occur. Any questions? Okay. So again, let's say right now that you weren't quite finished copying. You could go back later and copy it with the video, or you could take a quick picture right now if you wanted to and copy it later. Okay? Alright, let's move on. We're going to start with these graphs. And I want to give the domain and the range in interval and algebraic. And then we'll say if they're continuous or discrete. Okay, so here we go. Let's do the domain here. And let's do the range down here. Domain is x, range is y. Now, how many of you have been at the airport where they have that big old wand that they scan you with for metal? Okay? So, real quick, Drew, can you come here real quick? What I'm going to show you is, so Drew, put your hands out to the side. So Drew is basically showing you like the x-axis. So his hands or his arms extended out right now is the x-axis. So extend it again. If I want to scan for the domain, you can use your pencil, you can use your hand. You're going to scan this way for the domain. Okay, you with me? In other words, you're going to scan with a vertical line that is scanning what are all the possible values of x that will exist on his graph. Can you do that one more time? So as you scan for the domain, you're doing this. Okay? As you scan for the range, the y values, his body is the y-axis. You're going to scan with a horizontal line. You all with me? Okay, have a seat, please. So with that being said, let's scan. We have about 30 seconds before lunch. That's what that alarm was for. Let's scan this, and we're going to scan the x values for the domain. Okay? Here we go. Left to right. I want you to think that the graph are pieces of metal, and it will only beat when I'm right above it. Okay? So think that this red vertical line is like a metal detector, and over here, there's nothing. Silence. And then it's like, beep, beep. You with me? Okay, so real quick, the beep the beep at 2, is the metal detector beeping, yes or no? It is. It's not beeping for this one, but it is beeping for this one, right? So, tell me, what's the lowest x value that it beeped on? -6. Did it beep forever after -6? Including where it's at right now? Yes.
Yeah.
Okay, so we're going to put infinity. Does it touch -6? Does it include -6? So we're going to bracket that. Does it include, in other words, can I touch infinity? No. So because of the fact that I can't, it will always be parentheses. And we'll stop there and go to lunch. All right, so what we were just talking about, the domain. It is existing at x is equal to 6. Otherwise, it is beeping as far as that analogy with the metal detector. So we would go from -6 all the way through and go to infinity. Let's say some of you on the quiz did something that looked like this. Okay, so we're scanning it, and instead of -6 to infinity, you did -6 to or +2. You did a bracket, and you union it with a 2 to infinity, parentheses. This is what you showed. Do you think I'd give you credit for that? I would. That is still correct, but it's not the preferred way that I'd want you to do it. I'd want you to do it like this. Guys, right here that I'm highlighting in blue, does it fail the vertical line test? It does not, because it did not account for the 2 times. It accounted for it 1 time. It accounted for it on the first interval right here, and it just said anything and everything right immediately past 2 because it has parentheses. But again, please use this preferred one right here. All right, so now, with range, we are still scanning, but this time we're not scanning with a vertical line. We're going to scan with a horizontal line, going from the lowest y value and scrolling upward to the highest. So again, nothing, then beep, then it would be silence again, and then beep, whatever. Okay? So what's the lowest y value, anyone, that the range would exist? -4. And it's going to go, and it's going to exist until when? Not infinity. Remember, you're trying to look at all the breaks that occur, okay? -2. So you're saying from -4 all the way to -2, this is going to be the first interval that it exists on. What's the second interval? So it'll be union what? When does the range start to exist again? At 2. Well, let's do 2.5. Bless you. And 2.5 all the way to what? So from here all the way up to infinity. We know we'll never touch infinity, so that needs to be parentheses. Bless you. How about at 2.5? Would it be a bracket or parentheses? It would be parentheses actually, okay? Because it's not hitting 2.5. Let me show you that on the graph. So, scrolling down. So right here, at 2 on the graph, it's open. It does not exist y-wise. It does exist x-wise. Let me bring that back. So, come on. Maybe. X-wise, it does exist. Y-wise, it does not exist. You with me? Alright, so let me highlight it a little bit clearer for you. The y values will exist everywhere past this 2, so we're going to open it on 2 and up. And it exists between -4 and 2. That's where the graph exists, y value-wise. Or 2.5 is what I meant to say. 2.5 is where it starts, okay? And then x-wise, let's do an orange. From -6 all the way to infinity is where this would exist. You with me? In other words, as you scan, that's whenever that beeping sound is going to occur. Okay, so let me scan one more time. So right here, look at the graph, and at x is equal to -6, it's beeping. Everywhere where it's orange on the x-axis, it's beeping on the graph, x-wise, okay? And then y-wise over here, whoops, grab that, maybe not. Y-wise, there you go. It exists at -4 all the way to -2, so it's like silence, beep, 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 so on and so forth. Are we good? I hope the beep helps. Alright, so now let's do the algebraic notation. If I want to write -6 to infinity as an algebraic notation with inequality symbols and so on and so forth, anyone, how could I write -6 to infinity? Christina, what would I do? Less than infinity. So she is correct. It should be less than or equal to. That's how you have a bracket with -6. She's also correct that you could write less than infinity because you'll never touch it. But right here on this less than infinity, you don't need it. And please don't write it. I want you just to write this right here. You could say -6 is less than or equal to 6, x. Or you could say x's that are greater than or equal to -6. To me, I prefer that because it's showing you what I have here highlighted in orange right here. X's that are greater than or equal to -6. Remember, these two things mean the same. -6 is less than or equal to x is the same as x is greater than or equal to -6. All right, let's look at the y. Let's go with Gina. On the range, how would you write the inequality for y?
You do -4 is less than or equal to y is less than
Or less than
or equal to 2.
less than or equal to -2. Yeah. So this right here, we just accounted for this small piece right here. Okay, from -4 up to -2, y's do exist. Notice how we have the equal sign because there's brackets. Okay, it means they're touching. So again, if you have these equal signs, they're going to be brackets. Okay. No. So that's the difference between interval notation and inequality notation, or algebraic. Okay. And for this union, let's just put the word and. And now let's put from 2.5 and up. Okay? So, Aaron, how would I write this interval?
2.5 is less than or equal to y.
Okay, so it's just going to be less than y, okay? So 2.5 is less than y because we don't have this equal to here. It's just less than. Anyone else? What's probably the preferred way I would want you to write this on a quiz or whatever? Y is greater than 2.5. This is the way I prefer it. Okay, so that's interval notation. That's algebraic notation. Okay? Alright, so now let's move over to this one here. Okay? And let's scan the domain. Again, when we scan the domain, we're looking at scanning the x. So left to right, we're scanning left to right. Now, doing that, when does the domain exist? Anyone? Kaylee, when would the domain start to exist? Sorry, Abby. Are you Kaylee?
I'm Kaylee.
Okay, yeah, Kaylee. When would the domain start to exist?
Like, what do you mean start to exist?
So let's do an interval notation for the domain on this graph right here. What do I write?
I'm not sure.
Let's go Maddie back here. What would I write, Maddie?
It's -6.
-6. This is where you're starting. Closed or open?
Um,
Like bracket or parentheses?
parentheses.
Parentheses, because I'm not including 6. So look, this is what we're talking about. That's where we're starting. And then keep going, Maddie.
Comma to
Comma all the way to
5? No, 4. Sorry.
4. 4. So right here all the way to 4. And Maddie, do I include 4?
Yes.
Yes, so it's going to be closed. So that means what anyone would be here?
A bracket.
A bracket. Are we good? Alright. Yes?
If you were to put like, instead of putting -6 parentheses, could you put like -5 bracket?
Could you put a -5 bracket? Okay, so this is a really, really good question, okay? If I put a -5 bracket, that means it has to start at -5. Do we agree? If I put a -5 bracket, that means it has to start here. That means we wouldn't account for all of those points that exist right there. So this is a really good question. We want it to start at -6, but we don't want to include -6. That means we want to include -5.999999999 forever. Okay? And how do we show -5.9999999 forever? By doing -6 parentheses. It's a really good question. Okay? So you're starting immediately right after -6. Okay. Now let's look at the range. Sammy, go for it. How would the range be shown?
-5.
Yep, all the way to?
6.
Yep. And is it bracket or parentheses at -5?
Bracket.
And then how about 6?
Parentheses.
Parentheses. Perfect. Okay? Let's do the interval notations on both of them. Okay? So the interval notation over here for domain. Oh, sorry, not the interval. Thank you for that. Not the interval notation. We're going to do the algebraic representation. So Savannah, let's go ahead and do the algebraic notation for that -6 to 4. What would I do?
-5 is less than or less than
Less than
y.
or x, right, for domain?
So it's x is greater than. Oh, for domain?
Yeah, we're starting.
Oh.
We're doing the domain real quick.
-6
There you go. -6 is
less than
x.
is
Yep.
less than or equal.
Perfect. Okay, so the way I want you to read this is -6 is less than x, which is less than or equal to 4. Now, someone read it just now differently. Listen to how someone I heard just read this. Someone read x is greater than -6, and she was probably going to say after that, but less than or equal to 4. Would that be correct? That'd still be correct, but normally you don't read it like that, okay? You read it full left to right, because they will be doing this, or you do it the other way, because they will both be looking the other direction. Okay, they don't look opposite like that, okay? They're all going to eat the same direction, if you will. All right, Abby, let's go with the range. How would you show the range on this? Yep, -5.
It's less than or equal to y.
Yep,
It's less than 6.
perfect. And I forgot to answer the first one. Guys, is the first one continuous or discrete? It's neither, because discrete's just a bunch of points, remember? So they put neither, just put it's discontinuous. How about the second one here? Is this continuous or discrete? It's continuous. The shortcut is continuous. You can write without what? Picking up your pencil. All right. Let's move on. This one's different. Let's start with the continuous or discrete, guys. Which one is it? Discrete. Yeah, for sure. Now, if it's discrete, this is another big important concept, okay? We're not talking about all these numbers that can exist between like -3 and 6. We're not talking about all those numbers. We're talking about only specific numbers. Okay, so we're going to list them out. So when you have a discrete, you're going to list them out with braces, and they're each individually all going to be listed out. Okay, so Jack, what would I list out for the domain?
-7, 6.
Or -7, just the x values.
Alright, then -3,
-3,
2,
2,
and 7.
7. Perfect. Okay, so now we're going to go to range. Remember, domain is x, range is y. Shalom, what would it be for the range?
Be 6.
Okay, so no worries. So look, she was about to list off this y value. So the way we normally do domain left to right, I still want you to do the lowest y value to the highest y value. So you're going to list them like from bottom to top, y value wise. Go for it, Shalom.
Okay, -2.
-2, yep, that's the first one.
1.
1, and then
5.
5 and
6.
6. Perfect. All of them are listed out individually from lowest to highest, okay? Last question before we start on your homework. This is a big question. Are these commas the same as these commas were up here? No. Because these commas up here, we're talking about intervals that had pieces of continuity in it. There was a piece of continuous on that interval. And these commas over here that I'm highlighted in red, there's no continuousness between these points at all. They're like individual islands, if you will. You with me? Please understand the difference. So we have braces, which are these. We have brackets, which include. We have parentheses, which don't include and you'll never touch. And then that's it. I mean, other than listening in interval notation versus algebraic notation. That's it for notes. Any questions before we move on to the homework? Okay, so let's go ahead and go to the homework. Okay, so resuming the video. Guys, you may need to go to Google Classroom. Sometimes on these sheets when they copy, they don't copy all that well. So 7th period, and if you go to the post on instructions, you can see that right there, domain and range homework, this is a very good copy that you can see all the lines. If you look at your paper, not all the lines copied, okay? So instead of printing off 120 more copies, because that's how many algebra students I have, just look at what I provide online and then go from that, please. So you'll have to cross-reference sometimes if you can't see the lines, okay? All right, so here we go. Let's go ahead and begin with this graph right here. Everyone, if I scan for the domain, what kind of line am I scanning with? A vertical line. So let's think about a vertical line. You can use your pencil if you want, and you're going to scan left to right. Okay? What's the domain? Anyone? What's the domain in interval notation going to be? Yeah, some of you are analyzing and you're looking at how much do each of these lines represent. You tell me, how much does each of those lines represent? 2. Okay? So Nika, what would the domain be?
-2 is less than, or
Close. It's not going to be a -2. You're close. Like it starts right here.
-1.5.
Not -1.5, because each of them are 2. So then what would it be? It'd be -3. Because remember, each of these lines are -2. So halfway, you know what I mean?
Yeah.
it would be 1. So it's going to be at a negative 3 all the way to what? Anyone? No. Negative 1. Because look, it does not include at negative 3, and it does not include at negative 1, but it does include everything shaded between.
Is it parentheses?
Parentheses on both. Nicely done. Okay? Guys, make sure I can see your nameplates, because there's some of you that I want to call on, but I can't see your name, so please make sure your nameplate is up so I can see. Alright, so interval notation. We just accounted for that first one. Now we're going to union, and now we're going to count for the rest of this graph. Abad, what would I do from here? Yeah, for interval notation. I just did negative 3 to negative 1. Now what's the next interval?
Negative 1 and less than.
So negative 1, no less than, because this is interval notation.
Oh, right, yeah.
So and negative 1 all the way to what?
Infinity.
Infinity. Alright, parentheses or brackets, help me out.
Parentheses.
Parentheses on both, because they're open circles. They're not touching, okay? So open circles on both. I gave you the analogy with the door, right? As far as brackets and parentheses, I didn't give you the analogy? Okay. So look, brackets means that you will touch it. Parentheses, like we were talking about with Sammy, you'll get infinitely close, but not touch. Okay? For instance, let's say that I'm holding a 5,000 degree Fahrenheit iron in my hand, and I'm approaching, let's say, Sammy's face. Okay? So from here, she probably feels 3,000 degrees Fahrenheit. She probably feels 4,000 right here. And if I were infinitely going to approach her but never touch, would she actually experience 5,000 truly? No. She would get so close, 4,999.999, so on and so forth, but she would never experience the 5,000. What's happening there is that. Okay? So my high school math teacher showed me with brackets this. This bracket kind of looks like the edge of this door. So think of it like that. Nice big old corner and then straight down, and then a bracket at the bottom. And what he did was, is he put his finger here, and I'm going to let this door touch it. No, I'm not, because that would hurt. But if it did, right, if it touched it, that's including it. So a bracket you can touch, but the parentheses you'll never be able to reach it. You'll get close, but you won't reach it. Just like these parentheses show I'm getting close to negative 3, but I won't hit it. And then over here at infinity, I will get close to infinity, but I'll never actually touch it. Does that help? Yes?
So every time there's infinity, it will be like a parentheses after it?
Perfect. Yes. Anything with infinity will always be parentheses. Okay? Alright. So now what we just did is we did from negative 1 to infinity. So we highlighted the rest of this. So open, open, filled in between, and shaded everything to the right. That's what the domain looks like. Okay? Let's look at the range. What is the range? Anyone? Remember how much each line is worth. And actually, let me call on Emily. What is the range going to be for this graph?
Negative 7.
-7, comma,
Negative 5.
-5. Parentheses or brackets?
Parentheses.
Parentheses on both.
And then union.
Nice. Union.
Negative 5.
-5 all the way to infinity. Parentheses on both, right? Okay. So guys, what we just labeled just now is this. We started at -7, but it's open because we're not touching -7. Okay, we're getting infinitely close, like that analogy with Sammy and the iron, okay? So we put -7. We go all the way to -5. Whoops, that should be open. And we're shading in between. And then we go from -5 to infinity, and we're shading all of this. So what's in orange is the range notation. Okay? Alright, from here, I want to change interval notation to algebraic notation. Okay? So let's go with Megan. How would I change -3 to -1 into algebraic notation? Drew, help her out. How would I change -3 to -1? So what am I going to write it? It's going to be written in inequality form, right? Okay, so anyone, what is it going to be? -3 is less than x, which is less than -1. Perfect. Why did we not put equals? Because it's parentheses and not brackets. Brackets are touching, just like equals is touching. Okay? And then we're going to put the other one from -1 all the way to infinity. Emily, -1 to infinity. How would I write this?
X is greater than
Perfect. X is greater than -1. Some of you might have chosen to put -1 is less than x, and then you probably would have written a negative infinity, or sorry, less than infinity, and realized I don't need that. And yes, this would be the same as this. But again, I would prefer you write it like that.
So do you not put union for?
Correct. Real good question. You don't put a union. The only time you put union are right here in interval notations. And a good way to remember that, Aaron, is because these parentheses kind of almost look like sideways U's. Okay? So that's where you're going to use that union symbol. There are no parentheses or brackets up here. So you won't use the union symbol. You'll just write and. Okay? Alright, Shalyn, how would it be with the algebraic notation for the range?
You would do -7
-7?
is less than
Yep, less than,
y
which is less than,
-5.
perfect. And then, Shalyn, what would be the -5 to infinity in interval notation?
-5
Yep, -5,
is less than
less than
y.
y. Or she could have said what? Y is greater than -5. I would prefer that one, but either one will work. Okay? And then set notation. Set notation goes on to make it more formal to where you're just going to say it's the set of all x's such that, or that satisfy, are between -3 and -1 and are greater than -1. Close braces.
Do we not put another less than sign after that?
Yes, I just didn't. Thank you for attention to detail. Nice, Aaron. So x is, yeah, so you're just writing it out almost like a sentence, if you will. Okay? Let me do the set notation for the range. It's the set of all y's such that y is bigger than this, but smaller than this, and, not or, but and. Or means one or the other. And means both. And y is greater than -5. Please ask questions if you have them, because I'm only able to cover maybe 2 to 3 examples, and then the homework is this worksheet, basically front and back, that you're going to turn in next time. Alright. Any questions on this one that we just did? Okay, so let's go ahead and go to this quadratic x squared. Clear the screen. And let's look at the domain and range. Alright, so domain. We're scanning left to right with just a vertical line. Anyone, what's the first number that I'm going to write in interval notation? Negative 3. Nice. Negative 3 is where I'm going to start. Right here. Should it be open or closed? Parentheses. It's open. It doesn't touch. It doesn't include it. Okay? All the way to what? Negative 1. Nice. With a what? Bracket. So you're saying start at negative 3 but don't include it. All the way to negative 1 and do include it. Okay? Now what? Union. Parentheses. 0. Now here's a big question. There's nothing written here. So it could be one of two things. It could be a... Oh, you have an arrow? Okay, so for instructional purposes, I needed to tell you this anyway. On a quiz, on a test, anytime you see this where it doesn't have an arrow or a point, I want you to assume that it's an arrow. If it was a point, there will be a point. If I want it to be a point, it will be a point. But if it's nothing, I want you to look at it like if it was an arrow. Okay? So, if this was nothing, now I know you have arrows, but if it was nothing, I'd want you to do that. Okay? So now, it will be 0 all the way to what? Infinity. In parentheses. Yes, always parentheses on that infinity. Okay? Let's jump over to the algebraic notation now. Okay? Joseph, what would I do to write what I just did in algebraic notation?
So you would do -3
Is,
less than x
yeah, which is
less than or equal to
perfect. Keep going, Joseph. What's the other one?
and x
Yeah,
is greater than 0.
perfect.
Wait, where did you get the 0?
Because that's where it restarts. So it went from negative 3 open all the way to negative 1 closed. And we highlighted that in between. And then it starts back up at 0. At x equals 0. Okay? Because these are big, huge vertical lines. And then it just goes off to infinity. Go with me? Okay. Alright, so let's go with Abby. Let's do the range in interval notation. What's the lowest? Okay, so before you start giving me those numbers, I want to remind everyone that when we're scanning for the range, it's going to be a horizontal line. Lowest to high, down to up. Go for it, Abby. What would I write?
-2.
-2. Open or close? Or parentheses or brackets? Parentheses.
And then -1.
So, no, this is a big question. This is a big thing that we all need to pay attention to. Right here, guys, at -1, does this horizontal line hit the graph two different places? Yeah, but it can. It can. That's okay. Because I'm not doing the vertical line test right now. You with me? This is a horizontal line. Okay? So my question to you is, does the graph exist at y equals -1? Yeah, it exists two different places. You know what I mean? So is there a gap? Is there a break? Is there a jump? No. It will exist basically from -2 all the way. Let's go right here. What's this y value? Y equals what? 2, 4, 6, 7. Do you agree that this is y equals 7? Okay, so y equals 7. It doesn't exist here, but it does exist here. You with me? So my question to you is, anywhere on the graph, it can exist more than once. Does y equals 7 exist? Yes. So you would basically say from -2 to infinity. because there's no breaks. Even though I physically see a break in the graph, guys, this is huge, and this is the one that gets people in the first quiz. We're going to have our CFA next class, okay? It's a mini quiz. Y equals 7 does not exist here, but on the same graph, it does exist here. So technically, there's not a break. I would draw like this, from -2 all the way up. It will always exist as y.
So, on the quiz, or just anytime, would you call it continuous?
Yes. Oh, I see what you're saying. As far as a graph? No. Nice question. This is not going to be a continuous graph because you would have to pick up your pencil to draw it. But still, the range would be from -2 to infinity.
So the range is technically continuous, but the actual graph is
Okay, so this is a really good question. Guys, the range, she's saying, the range is continuous. Her idea of the word continuous is a little bit off right now. Okay? Continuous means this. Continuous means that you could draw something without lifting up your pencil. Could you draw this graph, period, without lifting up your pencil? No, so it's not continuous. But what you're saying is, this is the way I would want you to reword it. The range exists from -2 to infinity. Okay? Don't think of that as continuous or discontinuous. Okay? Another thing that people try to do is they try to overlap continuous with all real numbers. It doesn't mean the same thing. Okay? So just keep that in mind. Alright, so let's go, Aaron. Let's change this to algebraic notation. What would I do? -2
is
less than y.
y is greater.
Or you could have said y is greater than -2. Okay? And as far as the formal notation, it would be the set of all x's such that the first condition and the second condition. That's your domain. Whereas this one is the set of all y's such that y's are greater than -2. Real quick, what time's the bell ring, guys?
Well, dig it out,
2:20?
229.
2:29. Oh, okay.
229 is when the next class starts.
Oh,
Okay.
you might.
2:23, 2:22. Okay. All right. Cool. All right. Any questions before I move on? Because we actually have time to do one, maybe even two more, which is good stuff. Because I feel like you want to solidify it for sure before you go and do your homework. Any questions on these? Okay. All right. So let's do this one right here. Square root. Think about it. You're scanning domain, so you're scanning with a vertical line. And you can use your arm or a pencil. Where does it exist? Okay, I want you to use that word. Not where is it continuous. I want you to use where does it exist? Where does the metal be? Okay? Anyone, where do I start? At 0. At x equals 0. And it's going to go all the way to what? 9. Parentheses or brackets at 0? Parentheses. How about 9? Bracket. Okay, let's do the interval notation for the range now. Okay, what will the lowest number be if I scan for the range? 0. That's y equals 0. Parentheses or bracket? Parentheses, because it's open. There's no other y's anywhere that will make it be. Okay, now let's go up until when? 3. Bracket on 3 because it's closed. Okay? And then I'm going to do one after this that's, I'm going to try to make it difficult just so that you can see all the small little differences between things. The algebraic notation will be 0 is less than x less than or equal to 9. The algebraic notation here, 0 is less than y, which is less than or equal to 3. right? And then yes, the formal notation is just the set of all x's such that basically copy this over. And the set of all y's such that copy this over. That one was easy, right? That one wasn't bad. Okay. Is this a continuous function, the one that we just did, yes or no? Yes. Why? There's no breaks. You can draw it without lifting up your pencil. Okay? Now let's try to find one that's a little bit more. Okay, you tell me, guys. Look at all the ones that are left. Which one do you want to do together? Absolute value? Is it this one right here? Okay. So here we go. What am I supposed to assume exists right there? Arrows. Arrows. So if they are not on your paper, please put them on there. Okay? This right here, guys, is supposed to be filled in. So please put a dot there. And here we go. We're going to scan it. Left to right. What's the domain? Negative infinity to positive infinity. So you can put it like this. Or, if you're lazy, because a lot of mathematicians are, you could put a big old capital R with another leg. That's saying all real numbers. That means everything XY. Okay? That means decimals, fractions, whole numbers, anything. Okay, let's do the interval notation for the Y. So here we go. Let's scan. What's the lowest Y value? 0. Parentheses or bracket? Bracket. All the way to what? Infinity. Parentheses. So from negative infinity to positive infinity, notation-wise, algebraically, you're not going to put infinity with less than or equal signs. Remember, we didn't do that on the other ones. So you could just put all real numbers. And thank you for asking this question, because this is a good one to actually do. Algebraic notation over here starts at 0, goes to infinity. How could I write that out? Y's that are greater than or equal to 0. Perfect. So now my final form, this is why I say that this is an awesome question to have gone over, because I did not go over it during first period, but I will text them to remind to make sure that they watch this video. The set of all x's such that x's are an element of all the real numbers. This means an element of. It looks like a C with a horizontal line through it. Okay? So an element of all the real numbers. And this is just the set of all y's such that what you wrote in algebraic form. Okay? Now I'm going to do one that I'm going to try to get you with, and we'll see what you've kind of learned and whatnot.
I have one question about it.
Oh yeah, go for it.
I was gonna ask, actually, I think figure out whether it was rational.
I'll let you do the rest on your own, okay? Like for homework. But I want to give you one that looks like what we were talking about earlier, of when do you include it, when do you not include it. So let's go here. Let's go here. And we'll say that the graph looks like, say this, open, open, closed, open, like that. Alright. Let's give some of these values. So we'll say this is like 1, this is 2. We'll say this is negative 3. This is negative 4. And that's negative 4. Alright. So here's our graph, guys. First of all, there's something that's not drawn that I should probably draw right now before I start interpreting all of this. What is it? An arrow, right? So an arrow right here. Okay? So now we're going to scan with the vertical line from left to right, and we're going to scan the domain. Okay, so let's put it, I don't know, in blue. We're going to scan left to right. Where does the domain begin to exist? Anybody? Negative infinity, right? Way over here, it exists because this will go up forever, to the left and up. So we're going to say the domain is from negative infinity, parentheses, and it's beeping because those arrows show that it will be beeping as you go to the left. Come on. So, and it will tell me, when does it stop to beep? Now, right, at negative 3, it does not beep anymore. Do you see anywhere over here on negative 3 that it could beep somewhere else? No. So that's why you know that it will stop at negative 3 and not include it. You with me? So then, let's put a union. And the next thing it's going to do is what? From negative 3 all the way to what? Oh, I probably didn't write this down. Let's say this is 4 and this is 2. So from negative 3 all the way to what? 2. Open, open. You with me? And then from 2 all the way to what? 4. Do I close 4? Yes. And then from 4 all the way to what? Infinity. Open on infinity, open on 4. And some of you are looking at this right now, and you probably already identified that I could have just written that as what? I could have written that from 2 to infinity. You with me? Now let's scan the range for the y's. I will always give you 2 minutes to put away, so please don't pack up before, okay? So here we go. The lowest y value, where do I start? Oh, I didn't go all the way. Negative 5, right? Okay, here we go. Negative 5 is where I'm starting. Closed or open? Closed. All right, so when is the first gap that I have? It exists at negative 4. My question to you is, does the graph exist at negative 4 right here? No. But does it exist at negative 4 anywhere? Yes, it exists right here. So you're not going to put from negative 5 to negative 4. You're just going to keep going through like if there's no break at all. Okay? All the way till you get to this one right here. The graph does not exist here, but it does exist here. So will I put a break? I'll keep going. I'm not going to put a break there. Y'all with me? And then it stops at 2. So should I say negative 5 to 2, yes or no? No. Because of this thing, this 2 should be what? Infinity. With that. One thing that was included that we never really looked at was this piece here. You see that? Because this 5 was too low, it already accounted for it no matter what. Go with me? Hopefully that helped you determine the difference, what we're talking about with Aaron, of continuity, continuous, versus where does it exist. These are the hardest ones that I just showed you. Okay?
Will you go to the, like this page, because the lines are stuff
On this one?
just like go to
Which one?
the back
probably don't.
Okay.
Okay, sorry. Are there any other questions, guys, from what we did?
So this is the
Yeah, so your only homework is this sheet right here. Front and back. Please be neat, write neatly,